So in today's video, we will be discussing about Thevenins Theorem numericals. Okay, so in today's, this week, we'll be doing network analysis subject and we'll be mainly concentrating on the network theorems. Okay, that is Thevenins Theorem, Norton's superposition, maximum power transfer theorem, all these theorems, numericals, we'll be explaining. Okay, so I've done a detailed video on Thevenins Theorem, step-by-step process. Anyway, while discussing this question, I will be doing two questions in this video. In this video also we'll be discussing. Okay, so this is the circuit we need to simplify. There is a load resistance of 5 kilo ohm. So whenever we are having a circuit and when we use a load, our aim is to find the total voltage or the total current in the circuit, right? So in Thevenin's theorem, what we are doing is we are going to keep the load as it is and we'll be taking the remaining portion of the circuit, whatever it is, how many voltage sources there be or how many resistances or whatever there be, we are going to simplify the entire remaining circuit as a voltage source and a series resistance. Okay, that is, we will be doing a simplification. So our aim is to convert this given circuit in the form of a voltage source and a series resistance and connecting back the load so that we can now very easily find what is the, like if you see the circuit and if you see this one, this is a very simplified version, right? So very easily we can represent a network, right? So only there is one voltage source and a series resistance and then we connect the load across that. So this is the Thevenin's equivalent circuit and this voltage source we call it as ETH, which is Thevenin's equivalent voltage, and this is the RTH, which is the Thevenin's equivalent resistance. So while performing Thevenin's analysis or Thevenin simplification, our aim is to find what is ETH and what is RTH. Okay, so the load we will keep it as it is. Okay, now our aim is to simplify this connection into this form, right? I hope it is clear. So our aim is to find the ETH and RTH, right? Now what is ETH? ETH is the voltage coming across this load resistance. Now in order to find the voltage ETH, which is the voltage coming across this load resistance, what we do is we will simply remove this load resistance and we'll create an open circuit here. Okay, then that is ETH. Okay, so ETH is actually the voltage coming in this portion. That is the voltage across the load resistance, which we find by removing this load and creating an open circuit here. Again, next step is finding of RTH, right? Because RL is the same, we only require ETH and RTH. RTH is a Thevenin's equivalent resistance, which is the equivalent resistance of this connection without any sources. That is, we'll remove the load and we'll remove the sources and we'll find the equivalent resistance of the remaining circuit, and that is RTH. Now while doing this example you will be very much clear about these concepts. Okay, so now we are going to find ETH and RTH for this given connection. Okay, so as I said, I'm going to remove this as of now and I'm going to create a open circuit here. Okay, now I have created an open circuit. Now first step is to find the voltage. So first step, in this step we'll be finding ETH. Okay, our aim is to find ETH and that is the voltage in this portion that is coming across A and B. Now how to find the voltage? First we'll find what is the current in this portion. Okay, what is the current in this circuit? Okay, so the current, since here there is an open circuit, that is the 8 kilo ohm is actually connecting to a open circuit. So there won't be any current flowing through 8 kilo ohm. So the current will be flowing through 12K and also 4K, right? And that current is actually generated with the help of this voltage source. So what will be the current? Current I will be equal to 48 volt by 12K plus 4K, right? I hope it is clear. See, in order to find the current in this connection, we have to consider what is the current. I is equal to, what is the equation? I is equal to V by R. Now, V is the voltage. Only you can find one voltage source here, which is 48 volt. So, 48 volt by resistance. Resistance is the resistance through which the current is actually flowing. If you see the circuit, 8K is connected to an open circuit through which the current cannot flow, right? Since it is ending with an open circuit. So, the current will be flowing through the 12K and the 4K. So, total resistance is a sum of 12K and 4K. I hope it is clear. So, we are going to find what is the current. 48 by 16K it is, so 3 milliamps. So 3 milliampere is actually flowing through these two resistors. Okay. Now, we don't need current or anything. We require voltage across AB. Now, if you observe this circuit, you can see this AB and we'll call the voltage as ETH, right? The ETH is, or the voltage in those portion will be the same as voltage across this 4K, right? Because of the parallel connection. When two resistors, or consider two portion, there is an AB. Taking this portion where we want to find the voltage. And that portion is connected in parallel to a resistance. So whatever voltage is coming here will be the voltage across AB also, right? Because we know that for parallel connection, voltage is same. So, VAB or ETH, we can write like this. VAB is equal to, we have called it as ETH, that is equal to voltage across 4K. Very simple, right? So, in order to find ETH, we actually need to find what is the voltage coming across the 4K ohm resistance. The resistance is 4K, the current is I. Now what is the voltage? So voltage across 4K, we call it as V4 is equal to 4K into 3 milliampere, right? Is there any confusion? No, right? Very simple. Due to the parallel connection, this voltage is equal to this voltage. So voltage is resistance into current, which is 4K into 3K, which is equal to 12 volt, right? So we have now obtained this 12 volt is equal to VAB, that is equal to, we have called it as ETH, or that is the Thevenin's equivalent voltage. So our one portion of the Thevenin's problem is completed. Next aim is to find the equivalent resistance, that is a Thevenin's equivalent resistance. So I'm going to do the step 2. Many people do like various steps. I'm just following 2 steps. One step in which we will be finding the voltage. In step 2, we'll be finding the resistance. Very simple. Not going to do a lot of steps. You can do in various steps. First, draw the equivalent circuit, then finding of ETH, then RTH, then drawing of the circuit. Likewise, you can include various steps, but just anyway, same thing we are doing. Okay. So, RTH. So, in order to find the equivalent resistance, I'm going to remove all the sources. Only one source is here. And when a voltage source is removed, you know that you create a short circuit, right? So the resistance we'll keep intact. This one and this one. And this will be again open circuited. We are not going to keep the load. We don't need the load. Okay. So the load we have removed and we are keeping that AB. Then there is an 8K here. There is a 4K here. There is a 12K here. And this portion in which there was a voltage source, but we have short circuited it. Okay. So, in order to find this equivalent resistance, here we have to get the resistance of this connection. So, we have to look from this side. Okay. Not from this side. So, we have to look from this side because we are simplifying the circuit from this point, right? And then after simplifying, we'll connect back the load. Okay. See, if you do these type of problems, very easy because theorems always follow a standard methodology. There is no much of complications, but only thing is that you should be familiar with how to do this steps. Okay. So, if you look from this side, this resistance is an 8K, which is in series with this parallel combination. This 12K and 4K are in parallel combination. And 8K is in series with that parallel combination, right? So you can write the equivalent resistance like this. I'll write it here. RTH is equal to 8K plus 12K parallel 4K. Okay. So 8K plus 12K and 4K parallel means 12 into 4 by 12 plus 4. If you do it, you will be getting 3K. So 8 plus 3 is equal to 11K is the equivalent resistance or RTH. Okay, so we have obtained two values, VTH and also RTH. Okay, next step is to draw the circuit. That is the Thevenin's equivalent circuit. I'm going to draw back the previous circuit which I have drawn, which is having only a single voltage source and a single series resistance, and connecting back your load as it is, which was a 5K RL, which is value 5K ohms. Now this is 11K ohms. Here also there is ohm. Then this one is 12 volt. So this is ETH is equal to 12 volt. RTH is equal to 11 kilo ohms. So this is your Thevenin's equivalent circuit or connection. Okay, so this is how you simplify the Thevenin's questions. Okay, now next we can find the current in the circuit. Is it any difficult? No, it is very easy. We can find the current. Current IL is equal to, there is only one voltage here, which is ETH. ETH by, there are two resistors. Very easily you can identify that they are in series connection. 11K plus 5K. So ETH is 12 by 16K. So IL, you will get it as 0.75 milliampere. Okay. So the IL or the current flowing through this load is equal to, IL is equal to 0.75 milliamperes. Then if you want to find the voltage across this VL means, sorry, if you want to find the voltage across this RL, again it is possible. RL is equal, the voltage VL is equal to RL into IL. Okay, that also you can do. So now the voltage coming across the load will be VL is equal to IL into RL, right? What is IL? It is 0.75 milliampere into 5K. So that will be equal to 3.75 volt. Okay. So these type of questions can also come. What is the Thevenin's equivalent current, or what is the Thevenin's equivalent? No, what is the current in the Thevenin's equivalent circuit, or what is the voltage in the Thevenin's equivalent circuit? These type of questions you can face. Okay. So I really hope that you understood how to do this problem. We'll do one more problem. Okay. The next question is a little bit complicated one. You can see that there is the load which is connected across the middle portion of this network. Okay. The AB is the point across which we have to actually create a Thevenin's equivalent circuit, and the load is connected here. Now don't confuse with the equivalent circuit. It will look like only this. It will be like this only. The RL you will be connecting here. This will be your ETH again, and this is the RTH. And RL is equal to, here it is 40 ohm. Okay. Now we need to build a circuit like this from this one. That is our aim. So first step, I'm going to find the equivalent resistance first, then ETH. You can follow whichever one which is comfortable for you first. Okay. Anyway, we need to find both ETH and RTH. Okay. So first I'm going to find here what is the equivalent resistance. So that I'm going to put as step 1, finding of RTH. So while finding the resistance, equivalent resistance, you remove all the sources and you create short circuits. And also you create an open circuit by removing the load. Okay, just like we have done in the previous question. There is a resistance here which will keep it as intact. And A, B is the point where we have created a open circuit. Okay, there is a 10 ohm here, there is a 20 ohm here. Now we are going to look from this point. Okay, now what is the connection between 10 ohm and 20 ohm. So if AB was here, it would have been a series connection. But we are going to find the equivalent resistance across this point. So it will actually come as parallel with this 10 ohm. Okay. So RTH is the parallel connection, or the equivalent resistance is actually the parallel between 10 ohm and 20 ohm. So it is 10 into 20 by 10 plus 20, that is 200 by 30, or you'll get it as 6.67 ohms. Okay, so this is your equivalent Thevenin's equivalent resistance. Okay, so we have obtained RTH value. Next, our aim is to find the voltage, right? Thevenin's equivalent voltage. Now, Thevenin's equivalent voltage is again the voltage which is coming at this point between A and B. So why we are naming A and B is because we need to find the voltage and the resistance looking from that point. Okay. So in step 2, we are going to find the equivalent voltage, that is Thevenin's equivalent voltage. Step 2, ETH. Okay. So I'm going to draw back the circuit, keeping the voltage sources as same. There is a 10 ohm here, there is A and B here, and again there is a 20 ohm, and also there is a 20 volt here, 20 volt here, 10 volt, 10 ohm and 20 ohm. Now you need to find the voltage coming across AB. So next our aim is to find the Thevenin's equivalent voltage ETH across this 2 points A and B, which we have actually open circuited by removing the 40 ohm load. So before finding the equivalent voltage, we are going to find what is the current in this connection. Okay, so what is the total current in this connection? There are 2 sources, there are 2 resistors. These resistors are actually in series connection when it comes to the current flowing through this loop. Okay, so what is the current? Current I is equal to V by R. Now V, if you see these 2 voltage sources, they are in opposite polarity. So V will be the difference between these 2 voltage sources. So it is 20 minus 10 by, now we are going to find the current in this mesh. So these 2 resistors are in series, 10 ohm and 20 ohm, right? So 20 plus 10. Now 20 minus 10 is 10, 10 by 30, that is, I'll write the value above. I is equal to 0.33 amperes. Okay, so that is the value of current I in this loop. Now we don't need current, we require ETH, or the equivalent voltage across the points A and B. Now in order to find the equivalent voltage, or the voltage coming at this point, we'll call it as VAB. Okay, VAB will be, consider this portion of the loop. Okay, we can apply a KVL here and we can find what is the voltage coming here, right? So the voltage will be the sum of this voltage source and the voltage coming across 10 ohm. That will be the voltage VAB, right? So VAB equal to 10 volt plus 10 into, what is the voltage drop across 10 ohm? It is the resistor value into the current flowing through it. Okay, current we have found is 0.33 amperes. So I'll write it below. Okay, so VAB is equal to 10 volt plus 10 into 0.33, that is equal to 13.33 volts. We have taken this portion of this particular loop, and if you see this portion of the loop, you can assume that, or you can say that the voltage across AB or VAB is equal to 10 volt plus the voltage coming across the 10 ohm. So that's why we have taken 10 volt plus 10 into 0.33, which is equal to 13.33 volt. Or else we have considered now this portion, or else you can consider this portion where we'll be getting 20 volt minus, okay, 20 volt minus 20 into, current is same 0.33, In that case also you will be getting voltage across AB as 13.33 itself. Please try it out and you will get the same value. Okay. Anyway, the voltage VAB we have got is 13.33 volts, and that is nothing but equal to your ETH value. Now we have obtained both the values, ETH and also RTH. Now we can draw our Thevenin's equivalent circuit. Equivalent circuit, which is having a voltage source and ETH is equal to 13.33 volts and RTH we have obtained is 6.67 ohms. Drawing back my load as it is, RL is equal to 40 ohm. Okay, so this is my Thevenin's equivalent circuit, right? I can find the current I just as in the previous case, voltage 13.33, which is ETH by sum of these two resistors, 40 plus 6.67. So current obtaining is 0.286 amperes. Okay, so the current in this Thevenin's equivalent circuit I is equal to 0.286 amperes. Okay, so this is how you do problem on Thevenin's theorem. So Thevenin's theorem is actually replacing of a large network with a single voltage source, that is a Thevenin's equivalent voltage, and a series resistance. Okay, so that is called Thevenin's theorem. So this is how you do simplification of circuits into Thevenin's equivalent circuit by finding of ETH and RTH. Okay, and connecting back the load of whatever value it is, same as it is into the Thevenin's equivalent circuit. Okay, so I really hope that you found this useful. You understood the concept of doing these problems. If you found useful, please do give it a thumbs up and also share this video with your friends who's preparing for any competitive examinations or semester examinations. And if you want more videos, please do subscribe to the channel. Thanks for watching and keep on watching.